Hello guys, welcome to another video. In this video, we would be seeing on how we can create a RAG using Neo4j. We all know that Neo4j is a graph database. So everything is stored as a graph, right? So if we can even use this graph database for our RAG use case in GenAI. So let's see how we can do that, okay? So let's see on how we can read a PDF file or a text file and split it and store that into a Neo4j as nodes and relationships. Like in case if you are not aware of Neo4j, it's a graph database where everything is stored as a nodes and relationship. So I would recommend to watch any of the Neo4j tutorials before watching this. Like we have multiple Neo4j introduction tutorials in the YouTube, you can watch those. But on a high level, nodes are like entities. Let's assume like a person is a node, organization is another node. So now person and organization are connected using a relationship. The relationship here we can say like work set. So person works in that organization. Work set is a relationship here, and person and organization will be two nodes. So inside the person we can have multiple person details, and inside the organization we can have multiple organization details, and we can map them using the relationship. So in case if you are not aware of Neo4j, I recommend you to watch any of the Neo4j introduction tutorials. But now let's see how we can use this Neo4j database for the RAG use cases. It's just introduction video. In the next video, we will see how we can query and everything. But just a high level video, how to read a PDF file or a text file and load into Neo4j and query in the Neo4j. We'll see this. So now, if you see, I've created a virtual environment. I've installed the major package here called Neo4j Graph RAG. This is the package which we need to use in case if you want to do the stuff in Python, and also Neo4j package you have to install. That's it. So if you see, if we can create a free Neo4j database. You just go to that website and just click on start free trial. We can create it. You will get your database ID and all. So if you see here, when you go to this instances, this is the ID we have. We have to click on that ID I have pasted here, and this is a standard URL, this part and this part. That's it. And the ID, the user ID is Neo4j, and this is the password, and this is the database name. So if I click on query, if you see, this is the database name, Neo4j default database. So that's it. Now I have this particular file in my local. This is the same file they have explained even in the use cases in their documentation as well, but I felt like their documentation is not very clear. They just gave like this, so I thought let's explore it and make a video. And if you see here, we have multiple entities. Entities are nothing but nodes. So this is the Harry Potter PDF file. So out of this we have to extract the information or read the data from this PDF file, and store the data in the Neo4j in the graph format. Okay, so what kind of graphs we want to store, so that we can give it on high level. It's not that only this information will be stored or only these kind of nodes will be there. There will be other nodes will also be created, but in case if our LLM finds information something like this, then it will for sure store these. Along with this, it will create some other extra nodes as well. We'll see it, we'll run and see it. Now if you see, I need these three nodes: person, organization and location. And how do I want these three nodes to be linked using these relations? Like let's, if you see, person situated at this location, person interacts with other person, organization led by a person. This kind of relationship is what I want from this PDF file. Okay, so now if you come here, I have to create an LLM. This is the package, this is the class again imported from this Neo4j graph RAG only. That's it. And you have to, I'm using OpenAI here, the maximum number of tokens, the API key and everything, and I got the LLM here. That's it. Now we have to create the driver. Like to create the driver, we have to use Neo4j.graph database, the URI and the authentication. URI and authentication is these details like username and password and the database name and the URI. This ID is alone changes. Nothing else will change. It should be SSC only. If it is SC, we were not unable to connect to the Neo4j database. So that's it. So now we got the driver and we have an LLM. So we have a class called simple knowledge graph pipeline, simple KG pipeline. Using this, we can pass all the information. So the LLM, the driver details, what kind of embedding it has to use to store underneath, and what are the entities, what are the relationship, what is the potential schema. We are looking for these kind of schema majorly, so that our LLM will understand this and try to find out all these kind of information from the PDF and store it. So this is the database name we are giving. That's it. Now this is the knowledge graph builder we have, like just passing all these arguments to this class. That's it. So now if you see kgbuilder.run async and pass the PDF file name. Okay, that's it. So when you execute, our nodes gets created. If you see right now, we have only 3 nodes here, or 3 entities. Nodes and entities both are the same. But if you observe, there are multiple nodes created. 27 nodes are created. Like, it's not that only these 3 gets created, others will also be created. But if the LLM finds out the information which is in sync or related to this, these will be created for sure. Now if I go to my Neo4j database, I have 0 nodes, right? So now let me execute one by one. That's it. So now this is running. Once this is executed, we will have all the nodes created here. It's executed. So now if we come here, see, we are able to see the data. If you see, we are able to view all the person, organization, location. These are the 3 nodes we want, but along with this it has created some other nodes as well. So now if I click on this any of the node, I am able to query, right? Person, there are multiple person details, so we have to just zoom in. See, all these are the persons, and let's see based on the relation. See, the person interacts with other person, right? That's what we have given here. If you see, the person interacts with other person. So in our PDF file, let's see what are all the nodes created using this particular relation. So interacts, if I click, see. So if you see here, see, this Harry Potter interacts with Dobby, Harry Potter interacts with Tom Riddle, Harry Potter interacts with Hagrid, and again Hagrid interacts with Harry Potter. So all these kind of relationships, so we do, like, this information got extracted from our PDF file only, and it got stored. So now you can ask me, like, we have multiple vector databases, and why do we need Neo4j vector database again? Like, Neo4j database is not a competitor or a replacement of the original vector databases like Pinecone or Wayware or many other, right? It's just like it enhances, like, along with those you can even use these as well, where you have some connection between the data in your scenario. Then you can even add on with the Neo4j database as well over there in that use case, like so that the output when you query will be more precise, like the output from the vector DB and the output from Neo4j, both you can merge it and then give the precise output in those kind of RAG scenarios, wherever you have some kind of relational information, not just a plain textual information. These all got extracted from our PDF file. Similarly, you can even do the textual information as well. So now if you see, I have textual file. If you see, the KCR is the Chief Minister of Telangana, Telangana is a state in India, Infosys is an office in Hyderabad, some kind of information I have. And now if you see, I have multiple entities, person, organization, city, state, country, river, some kind of information. This is a textual information related to Telangana state. Okay, so now I have the potential schema. So I want all these kind of relations to be fetched from this text. So now if you see, I have given the potential schema. Person leads a state, a chief minister leads a state, right? So we should get like KCR leads Telangana, something like that we have to get. So state located in country, so we should get like Telangana located in India. So organization has office city. So here if you see, Infosys has office in Hyderabad, so that information should come here. So let's execute and see this as well. And the class and everything is the same, we don't have to change anything, only that here we have to pass textual information, and in this simple kg pipeline we have to pass from PDF equal to false. By default this will be true, so we have to explicitly make it as false, because we are not writing the data or reading from that PDF file, so we have to make it false explicitly, and then execute this. And now if we go to the this Neo4j database, we'll get more informations as well, more nodes as well. Right now we have only 27, now it has moved to 37. So now if you see, has office, see, I don't know why we have got 0 here, but ideally when I tried, we have got KCR leads Telangana. That's what the information I have got, but somehow we are not seeing that. But let me rerun one more time. See, now we have got it. If you see here, Infosys has office in Hyderabad. See, Hyderabad is capital of Telangana. So this kind of information. Hyderabad is founded by KCR. See, all this kind of information we have extracted from our textual data, whether it can be PDF or a text file or a string. We are able to extract that information and store it in our GraphDB. So now in the next tutorials, I will show you how we can query this information from this GraphDB and use it in our RAG use cases. So the overall intention is, if you don't have any relationship in your data underneath, then you don't have to use this Neo4j. So only when you have some relation in your data and you have to highlight it while responding to the user query in the scenarios like RAG, then you can come to the Neo4j. That's it. Thank you so much for watching.